Okay, so we're gonna do a continuation now of the symmetry and odd and even functions. This is part 2 of 2, and now I'm going to show you graphically how even functions are symmetrical and how odd functions are symmetrical. So I'm going to draw a graph really quick. Nice. Okay. And we'll use different colors because I've been using weirdo colors this whole time. This is the graph of x squared. Parabola. Sorry, my Spanish is getting mixed in. Palabra. This is a parabola, and it is the graph of f of x is equal to x squared. And look, it has an even exponent on it. So this is automatically an even function. The graph of x squared is an even function. Any parabola is an even function. And how do we graphically know what an even function is? Well, an even function is any function who, when you flip it along the y-axis, it looks exactly the same. So if you flip this, you get the same function. How about the graph of negative x squared? It too, I'll say g of x is equal to negative x squared. This too is an even function because if you flip it along the y-axis, this goes to this and this turns into this. It's the same function on both sides. So key word here is flip along the y-axis. It's an even function. So what about odd functions? Alright, what about odd functions? Well, let's plot an odd function. Let's do x cubed. X cubed looks like that first, and then something like that. So x cubed. We'll call this f of x again. All right. So look at how is this symmetrical? Okay. If I'm just going to tell you right now, if you can flip this 180 degrees and it still looks the same, if you flip this 180 degrees and it looks the same, then it's an odd function. Odd function. They say it's also odd if you flip it along the x-axis and then the y-axis. So if you flip this along the x-axis, you get this, right? And then if you flip it the blue along the y-axis, then you get this, the same function you started with. So that's how you graphically define an odd function. So also they say odd functions are symmetrical with respect to the origin or y equals x, which is basically flip it along the x-axis and then flip it along the y-axis. Same thing. I like remembering flip it 180 degrees, turn it completely upside down, and if it looks the same, then it is an odd function. So let's do some examples. I'm just going to do 2 y-axes and 1 x-axis to make it nice and nice. Alright, so how about well, I think you know what that is already. And what about these are just the same. This is a parabola, and of course this is some function to an odd degree. most likely one greater than 3, but still odd. So this, as you know, I hope you know, let's try, what does brown look like? This is an even function, and this, if you flip it completely, if you flip it 180 degrees, this goes here, and this goes there. Ooh, kind of looks like yin-yang. So this is odd. This is symmetric with respect to the x-axis, so it's even. This is symmetric with respect to the origin, so it's odd. So that's basically it. Symmetric with respect to whatever and whatever, and dang flabbit, I messed this up. Well, whatever. So you guys get the point. You understand all this symmetry with odd and even functions. So even functions symmetric with respect to y-axis, or yeah, y-axis. Odd functions with respect to both y and x-axis. And here are your examples. So I hope to see you all in future episodes. I'm still going to keep going through the book, and we're almost finished with actually section 1.1 in Stewart's Calculus 7th edition.